So in this video today, we're going to go over the properties of logarithms, and the three properties that we're going to go over are the product, quotient, and power properties. So our essential question is what operations can be done to logarithms, and then our learning objective is to use properties to simplify logarithmic expressions to translate between logarithms and any base. So because logarithms are exponents, you can derive the properties of logarithms from the properties of exponents. So we're going to put logarithms here. So just remember, we can use those properties of logarithms of exponents to do the properties of logarithms. And we're going to talk about that in a minute, okay? So remember that to multiply powers with the same base, you add the exponents. So this then translates to the product property of logarithms. So the logarithm is a product of the logarithm of a product is equal to the sum of its logarithms of its factors. Okay, so notice here that we've got a multiplication sign there, and we can then break that up into adding like we did up here. This is multiplication right here, right, between these two functions. But then when we translate it, it then becomes addition. So that's what we're going to do here too. So when we have the log base b of m times n, if we want to again expand it, what we're going to do is we're going to say log base b of m plus log base b of n. Okay, so we're going to also do that with our quotient property, which is division. So here again, when we have, remember that to divide the powers with the same base, you subtract the exponents, right? Because whatever's in the denominator is a negative. So the logarithm of a quotient is the logarithm of the dividend minus the logarithm of the divisor, okay? So here again, we've got log base 5 of 16 over 2. So we're going to do log base 16 minus log base 5 of 2. Log base 5 of 16 minus log base 5 of 2. And the algebra property over here is log base b of m over n is equal to log base b of m minus log base b of n. Now we're going to do a couple of these, okay? So on this first one, it says write the expression as a single logarithm and condense the expression. So we're going to first thing you always need to be looking for is, do we have the same base? Well, in this case we do. It's log base 4. So we're going to say log base 4 of 2 times 32. So just think, this right here, again, when we condense it, it's going to change to multiplication. So this is going to be log base 4 of 64. You don't have to put that parenthesis there, but that's it. And then obviously we could evaluate this based on the stuff we've already learned. But right now all we're doing is condensing, expanding, okay? So here again, we got log base 5 of 625 plus log base 5 of 25. So here again, we've got the same base twice, log base 5. So we're going to do 625 times 25. So this is going to be log 5 of 15,625. Okay. So on the next one, again, notice we have the same base, log base 3 of 10 minus log base 3 of 5. So when it's minus, we're going to divide. So we're going to say log base 3 of 10 divided by 5. Well, that can be simplified because 10 divided by 5 is 2. So we're going to say the log base 3 of 2. And again, we know by the change of base how we could solve that. So on this one, again, same base, log base 7 of 49 minus log base 7 of 7. So we've got log base 7 of 49 divided by 7. So this is going to be log base 7 of 7 because 49 divided by 7 is 7. So with the U-tries, what I'd like you guys to do is try to attempt this and then come back to me when you're done. Okay, so first thing I notice is that they've all got a log base b, a log base b, a log base b. So we got log base b of 4x. So we're going to say log base b of 4x. And then we got this minus. That means this is going to the denominator, this term. So then we're going to put that 3y down here. And then we got another plus. So this one's going to go on top. So this is going to be y, and which means it's going to be multiplied, right? So now what we want to look at is, can we simplify this at all? Well, I notice that I have a y on top and a y on bottom, so those can cancel each other out. So It's going to be log base b of 4x over 3. Here again, let's see if you guys can do this and then come back to me when you're done. Once again, we have the same base, log base 7. So we have log base 7 of 3y. So we're going to put log base 7 of 3y. And then we have this minus. That means this one's going to the bottom. So that's going to be 9x. And then we got plus. That's going to the top. So that's going to be 6z. Now, hopefully you remember that when we have coefficients out front, we can simplify those. So this is going to be log base 7 of 3 times 6 yz over 9x, which is going to be equal to log base 7 of 18 yz over 9x. And once again, hopefully you can see that these are coefficients and they can be simplified. 18 divided by 9 is 2. So our final answer is going to be log base 7 of 2yz over x. All right, so now we're going to talk about the power property about logarithms. So because you can multiply logarithms, you can also take powers of logarithms, okay? So when we take anything to a power, it means it exists 3 times. So the logarithm of a power is a product of the exponents, the logarithm of the base. So notice we've got the 10 to the third here, so that means there's 3 10s. Y'all notice that? So when we do this, we could say we have the log of 10 plus the log of 10 plus the log of 10, which means we have 3 of those. So it means ultimately what this means is we can move this out front because there are 3 of them. So anytime we have an exponent, we can move it out front, which is what we did right here. Okay, so that's what we're going to do as we work through some of these next problems. So for the next one, we have expanding this. So once again, we're going to take this exponent, we're going to move it to the front. So this is going to be 2 log base 4 of x. On the next one, we're going to condense it. So we're going to move this way as the exponent. So this is going to be log base 5 of y to the 6th. Okay? So now we're going to work a couple together, and then I'm going to have you guys do some. So we got our log base 8 of a squared b over c to the 3rd. Okay? So we're going to step this out in our process. We got log base 8 of a squared plus, because the b's on top, log base 8 of b, and then we're going to do minus for the c to the 3rd. Log base 8 of c to the 3rd. Now our next step is going to be move these exponents out front that we have. Okay, so we're going to move both of these out front. So this is going to be 2 log 8a plus log base 8 of b minus 3 log base 8 of c. So on this next one, I want to talk to you all about something. So before I ever expand something, I want to simplify. So if I can simplify, I'm always going to do that first. And hopefully you guys can see that we have an x on top and an x on bottom. So this is x to the 9 minus 4, which is equal to x to the 5th. Okay, so if we are to simplify this, then this is going to be equal to log 10 x to the 5th y over z to the 5th, okay? Because we were able to simplify that x to the 4th and the x to the 9th. So then we're going to actually step through this. So then we got the log of 10 plus the log of x to the 5th plus, and these are all plus because they're in the numerator, the log of y. Then anything that's in the denominator we're going to subtract. So this can be minus log of z to the 5th. Now once again, remember, if we have an exponent front, right? This is going to be log 10 plus 5 log x plus log y minus 5 log of z. Okay? And if any of these were like terms, we could combine them, but none of them are like terms. So, all right, so I'd like you to try this one and then come back to me when you're done. So on this one, I've got log base 3 of 7 plus log base 3 of x to the 6th plus log base b of y to the second. Here again, I'm going to move these exponents to the front. So this is going to be base 3 of 7. But this one's going to become 6 log base 3 of x plus 2 log base b of y. All right, last one. Go ahead and do this and then come back to me when you're done. So hopefully you notice with this one that we have 4 over 16 reduces to be 1/4. And then here again we have x to the 2, which is equal to x to the negative 2, which means it's really what? 1 over x squared, okay? So this is really going to be log base 2. We're going to simplify first, of 1 over 4x squared y. Okay, now we can expand it. So we're going to have log base 2 of 1, which was what was in the numerator. Then we're going to subtract what's in the denominator. Log base 2 of 4 minus log base 2 of x squared minus log base 2 of y. Now, is there anything that we can move out to the front? I noticed this. We can move that out front. I don't see any other exponents that we can move out front, so our answer is going to be log base 2 of 1 minus log base 2 of 4 minus 2 log base 2 of x minus log base 2 of y. And remember, when we get to evaluating, we could evaluate log base 2 of 1 minus log base 2 of 4. Those would be able to be evaluated and combined because they are like terms. Now the next two we would not be able to because we have an x in one and a y in the other.